Hello students, I hope you all are doing good. So if you have been following my mathematics series, so till now we have covered straight lines and trigonometry. Now we are starting with differentiation. Okay, so this is the first video of differentiation. Okay, so let's get started. Let's not waste a lot of time. Okay, so uh, okay, so this is the beginning of the calculus part. So actually, limits is a very important topic that should have been covered in the that should have been in the syllabus, but it is not there. So without knowing limits, you cannot understand the idea of differentiation. So in today's class, what we will be doing is we'll be trying to understand what exactly is differentiation. Okay, and in the coming classes we will be solving problems and the methods that we can use to solve the problems. Okay, but today's classes only on the focus will be only on the conceptual part. Okay, so let's check out the syllabus that the DCET has given us. So it is derivatives of continuous functions in intervals, so rules of differentiation, successive differentiation, and applications of differentiation. These are the four topics that is there in the syllabus, but today's session is just a introductory session. So in today's thing we'll be covering what exactly do we mean by differentiation. Okay, so we'll take a very interesting example and try to understand. So uh, I hope everyone knows what the basic laws of motions. Okay, these three equations, v is equal to u plus at, and you have got s is equal to ut plus half at square, and v square minus u square equal to 2as. These basic equations of motions, I hope everyone knows, right? Everyone knows this, these three, right? Okay, so okay, let's take an example. Okay, say we have a person who is standing at the terrace, like at the top of the building, and he throws a stone. So he's throwing a stone down. Okay, using this case, we'll try to understand differentiation. Okay, so simple things using laws of motion. Let's analyze this case. Okay, so he's not throwing, he's just dropping it. He's just dropping like this. Like this, he's dropping the stone. So initially, what will be the velocity? The u is equal to 0. What will be v? Using the laws of motion, and the acceleration a will be g, right? 9.8, right? This is our acceleration in this direction. Okay, due to the gravity, it is falling down, so the acceleration will be 9.8, that is constant. So using laws of motion, now tell me, I want to know what will be the velocity at time t equal to 2 seconds. Okay, tell me, just try. I hope you just try, pause and try. Okay, okay. We'll just find that out. We know this equation, v is equal to u plus at. So using this equation, I can find out the velocity at time t equal to 2 seconds. So u is 0, my acceleration is 9.8, my time is 2 seconds. So the velocity is how much? Close to 19.6, I guess. Yeah, so close to something. Okay. So this is the velocity at time t equal to 2 seconds, right? The velocity is changing throughout the journey, okay? But the velocity is at t equal to 2 seconds, the velocity is 19.6 seconds, okay? So this is using laws of motion, we were able to find out, right? So let's just keep this thing, okay? So what we have found out, v is equal to 19.6 meter per second. This is our velocity. This is at t equal to 2 seconds. Okay. Okay. So this is using laws of motion. We have arrived at this. Suppose, now tell me, to find out the distance of the stone from its this point. From this point, if I want to know how much distance it has traveled for any given instant of time, how do I find that out? We'll make use of this formula: v square minus u square is equal to 2as, right? So our v sorry, not this formula, this formula won't work. We'll use this, s is equal to ut plus half at square. Ut will be 0 because u is 0, half at square. So distance at any time at any instant of time can be found out using this formula, 9.8 into t square. So this is nothing but 4.9 t square. So this is my distance thing, right? So s is equal to 4.9 t square, and v at t equal to 2 seconds is 19.6, right? These two things are very important. Okay, so distance at any time instant can be found out using this equation. At time t equal to 0, the distance is 0 because it is just here. At t equal to 1, what is the distance? So we'll be doing that. Okay, so our idea, I'll just okay, just bear with me, just follow. Okay, so we have come that the distance can be calculated using 4.9 t square. Everyone agrees here? So for different time intervals, we will be calculating the distance. Okay, at a time t equal to 0, at a time t equal to 0, what is my s? S is equal to 4.9 into 0 square, which is 0. So distance is 0, obviously. At a time t equal to 1, my distance is 4.9 into 1 square, which is 4.9 meters. So at t equal to 1, it is 4.9. Then for t equal to 1.5, s is equal to 4.9 into 1.5, and so on. Some number you'll get, you just calculate that. Okay, okay, you'll get some number. So I have already done the calculation here in the next slide. So here what I have done is, for all using this equation, s is equal to 4.9 t square. Okay, I have found out for various time intervals what is the distance for 0, 1, 1.5, 1.95, 2, 2.05, 2.1, 3, 4. Okay, okay, fair enough. I hope till here it is clear. Okay, what I have done. Okay, so our thing will be, so we found out the velocity at a time t is 19.6 using the formula. But using a derivation approach, using a derivative approach, we'll be finding out this thing, the velocity at a time t equal to 2 seconds. Okay, the velocity, we'll be trying to find out the velocity at time t equal to 2 seconds. The distances, so this is our time versus distance, right? Okay, so till now everything is clear. Key, using the idea of differentiation, we will be finding out velocity at time t equal to 2 seconds, right? Okay, so what do you mean by average velocity? Tell me, what is average velocity? Distance traveled, distance traveled divided by time, time taken, right, in that interval, time taken, right? Okay, so to find out the velocity, the instantaneous velocity at time t equal to 2 seconds, let's take this interval 0 and 2. Between the time interval 0 and 2, what was the average velocity? Average velocity, the interval is 0 to 2. Okay, okay, so what is the distance traveled? 19.6 minus 0. What is the time taken? 2 minus 0. So this comes out to be somewhere, how much? Close to 9.8. Okay, 9.8 meter per second. Similarly, here I have taken this interval between 0 to 2. Now I'll take this interval between 1 to 2. I'll take the interval 1 to 2. Average velocity between 1 to 2. Okay, so now, so the distance is 4.9, 19.6. So I'll subtract 19.6 minus 4.9. Okay, and here the time is 2 minus 1. Okay, so this will give me some number. So what will be this? I don't want to go into the calculation. This will give us some number. So this is the average velocity. So uh, okay, so coming to the next slide, what I am trying to do is I am taking different intervals. I took 0 to 2 and found out the velocity, and then I changed the interval. I took 1 to 2. There we'll get 14.7, and then I'm taking 1.5 to 2, then 1.95 to 2. So you can observe what I'm doing. I'm getting closer and closer to 2. I'm making this interval smaller and smaller. Okay. So, and I'm trying to find out the velocity. And the velocity is approaching a number. You can see it increases here rapidly. It increases from 9.8, then it becomes slightly constant. Okay. As the time interval, as the we take this smaller and smaller intervals, this value starts getting limiting. It gets to a limit. So this is, we are approaching from the left hand side. Okay. If you take a graph, okay, this is our 2, this is our 0, 1, 1.5, right? So what we have taken, first we took 0 to 2, then we took 1 to 2, then we took 1.5 to 2. Okay, so we are going from left to right in this direction, very important. So this is our left hand limit. We are taking numbers from left and we are going left to right. Well, the idea is to find out the instantaneous velocity at time t equal to 2 seconds. Okay, this was the thing. So this is from left to right. The same thing we'll be doing from right to left now. Okay, right to left. Let me just show you that. Okay, so from right to left, the intervals we'll be taking is 4 to, between 2 and 4, then between 3 and 2 and 3, then between 2 and 2.01, and then 2 and 2.05. Okay, so intervals 2 to 4, 2 to 3, 2 to 2.01, 2.205. So again the same thing, I'll just write it down. This is our 2, this is our 3. Sorry, one second. Mm, let me take this as 3, this is 4. So this is somewhere 2.1. This is 2.1. So first we took this interval 2 to 4, then 3 to 2, 2.1 to 2. Okay, so we are going from right to left. So this is our right hand limit. In that case, what we were doing, we were going from left to right. So that was our left hand limit. Left hand limit. And this is our right hand limit. Limit. So you can see here, the number is approaching. Here the number is decreasing, decreasing, and decreasing, and it is limiting. It is limiting to 19.48. Okay. So now let's get both the things, left hand and right hand thing. Okay. So see, this is the left hand limit. This is the same data. So this is our time and distance thing that we got from this equation, s is equal to 4.9 t square. Using this equation, we found out this data, and our interest is to find out the velocity at time t equal to 2 seconds. Okay. So what we did was we took the left hand limit and then the right hand limit. Okay, so we took the intervals from left and from the right. So this starts decreasing. Okay, observe that the difference between these two is very less. It becomes small and small and small, and we'll approach to a value. So you can see this is approaching to a value. From this, tell me, just pause the video and try to understand. You'll get that. Okay, just analyze the cases. Okay, what is happening here? From this data, I can easily say that the instantaneous velocity at time t equal to 2 seconds is between is going to be between 19.335 and 19.84, somewhere in between. Okay, So that is my instantaneous velocity. So what we found out using laws of equation, that is v is equal to u plus at, that gave us around 19.6. So using this method also we'll get the same thing, right? So as and when as we take smaller and smaller values, we'll get these kind of, we'll approach to the exact thing. So from this thing we concluded, right, the instantaneous velocity lies in between this only. Okay. Okay, so this is the limits idea. What I was trying to convey you is the idea of limit. Using the idea of limit, we found out the velocity at time t equal to 2 seconds using time and distance data. Okay, okay. So now coming to the graphical approach, this is very important. Okay, so this graph, what you see, this black color graph is nothing but s is equal to 4.9 t square. So the same thing, using which we plotted our this thing values. Using those values, we found out the velocity. So this is our distance versus time. So this is distance versus time, right? Okay. So here they have only taken the right hand limit. So t plus t2, sorry, 2 plus t2, 2 plus t1. So this is 2 plus t1. Sorry. This is just t1. This is my t2. Okay, this is t2 and this is t1. Okay, so the same thing. They are taking the interval c 2, 2 plus t2, 2 plus t2, and this is the distance at 2. This is the distance at 2 plus t2. And what they have done, to find out the velocity, what we do, we take the total distance traveled between that thing, that is nothing but c2 b2, right? This is the distance traveled between that interval, and this is a time interval. The time interval is nothing but t2, right? t2 t2 is nothing but ac2, c2a, this thing, right? Okay, similarly for this interval t1, same thing again, we'll be taking the distance traveled in that interval, that is b1 c1 divided by ac1. Okay, so from this what you can make out, there is a very interesting thing that you'll make out. So using these things, the ratio is remaining same, right? As this t becomes smaller and smaller, what happens? What happens to this line? This line will become tangent at t equal to 2 seconds. Okay, and the slope that this line makes, let it be angle theta, and let it be angle theta. Tan theta is very important. This is equal to tan theta as we take smaller and smaller value. So actually tan theta is the derivative. Tan theta is the derivative of s equal to 4.9 t square. Derivative of s equal to 4.9 t square at t equal to 2 seconds is nothing but tan theta. The value of tan theta is the derivative. Okay, very important. Whenever you think of differentiation, think of it as the slope. The derivative at a point will give the slope, will give the slope. Now coming to the actual definition, very important. This is the most important part of the thing. Okay, so this is our distance time graph. Let me take this point as t comma f of t, right? T comma f of t. T is the time and f of t is the distance. And let me take this as t plus delta t and f of t plus delta t. Okay. Okay, so we have got 2 points, t comma f of t and t plus delta t comma f of t plus delta t. Very important, guys. Okay. So tell me, you have got 2 points. You will apply the 2 point slope form. Okay, 2 point slope form everybody knows. I hope everybody knows if you've been following my lectures. F of t plus delta t minus f of t divided by t plus delta t minus delta t. So this comes out to be, the final equation comes out to be f of t plus delta t minus f of t divided by, oh sorry, this is t, no, this is t, so delta t. And here I have to put a limit because delta t tends to 0, then we'll get the accurate value. This is given by like this. So this is the derivative. F dash of t is given by this thing. So the derivative of f at t is given by f of t plus delta t minus f of t by delta t. Okay, as the interval becomes smaller and smaller, you get the slope. Okay, so that is what we did. So this is the equation that we have been using. Our delta t was initially large, and as the delta t became small and small and small, we got the exact velocity at time t equal to 2 seconds. Okay, so what is derivative? Derivative of a function gives us the slope, at that particular point the tangent makes. Okay, what does the derivative give? Derivative gives us the slope. Okay, there is some tangent, the tangent at that point. Okay, it makes some slope. That slope value, tan theta, this is nothing but tan theta, this is equal to tan theta. Okay, derivative gives us the slope. Okay, slope tan theta. So this is the thing. I hope this lecture was clear. You can rewatch the video. I have tried to explain you the idea of derivation. So if you know exactly what do you mean by derivatives, then applications of derivatives will be very interesting for you to understand. Okay, then only you can understand applications of derivatives. Without this, it will be very difficult. So the simple thing from this video, I would say, is derivative gives us the slope at that particular point, the tangent, the slope of that tangent. Okay, remember this much, that is enough. Okay, derivative gives us the slope at that particular point, slope of that tangent. Okay, so this is the important equation that we have established using a simple thing, a dropping of stone from a building. Using that case, I tried to explain you this. Hope this session was helpful to you. If you learned something from this, please press the like button and subscribe to my channel. You can subscribe to my channel and you can join my Telegram group so that you will get all the latest updates. And from the next class, we'll be solving problems. It will be mostly problem based. So this was just a idea. I wanted to convey the idea of derivatives. Yeah, that's all. Thank you.